On the video, and today we're going to have a look at finding percentage uncertainty and also looking at how uncertainty can be affected by squares, multiplication, division, etc. So just to start off with, it tells you an experiment where putty is put into different shapes and its resistance is tested. It says vernier calipers, which are high resolution devices that measure small changes in distance, are used to measure the diameter of the cylinder that's made by the putty. It says suggest a problem using calipers for this measurement. But if we think about it, putty is kind of like a rubber material, kind of like Play-Doh. So if you put something on two ends of a putty, it will squeeze the putty together, which will give an inaccurate measurement. So the material of putty may be compressed, may be pushed together when both ends of the vernier caliper are put on the ends of the putty. When inside the vernier calipers. Great. Now let's move on to something a lot of students misunderstand, which is finding the percentage uncertainty in a mean. How you know you have to use a mean for this is because it gives you multiple values of the diameter and it asks you for just the uncertainty in the diameter. So when you're calculating the mean, you exclude anomalies, but in this case there actually are no anomalies because all these values, they're pretty close to each other. So we actually calculate the mean by adding up all the diameters and dividing by how many diameters there are. So we do 34.5 plus 34.2 plus 32.9 plus 33.4 plus 34. So we add all those together and we divide by how many diameters we're including, which is 5 diameters. I'm just going to quickly do that on the calculator. 34.2 plus 32.9 plus 33.4 plus 4 over 5, and that gives 33.8. Before we do the rest of this question, so that's the mean diameter, by the way. Before we do the rest of the question, let's talk about how we can actually find the percentage uncertainty. I'm going to do this in a different color. Percentage uncertainty itself is the absolute uncertainty. Again, this only applies to a mean. And we then divide by the mean value and multiply that by 100. So we found our mean value now, it's 33.8. How do we find the absolute uncertainty? Well, actually, in a mean, we halve the range to find the absolute uncertainty. Now, when you're finding the range, that's the highest take away lowest number, but you also don't include anomalies. Like I mentioned before, there are no anomalies here. So taking the highest number, 34.5, and taking away from that the lowest, which is 32.9. Well, 34.5 take away 32.9 is actually 1.6. And if we halve the range, so half of 1.6 is 0.8, meaning our absolute uncertainty in this experiment is 0.8. Our final bit of working out is putting the absolute uncertainty over the mean, so over 33.8, and then multiplying all of that by 100. So I'm just going to quickly do that. 3.8, and it should give you the value listed here. So it gives 2.37%, which is around about 2.4%. So that's fine. Let's write that out. 2.37%. Great. That's everything you need to know for that question. Let's move on to this 4-mark uncertainty question. So let's use this blue. Determine the uncertainty in the volume of a cylinder. So what we know about a cylinder is it's a 3-dimensional shape where the volume is given by the cross-sectional area, pi r squared, multiplied by the actual length of the cylinder. Now what we are dealing with is the diameter, because that's what it's given us before, and also it's given us a length. So since we know the radius is half the diameter, what we can say is that r squared is just the right hand side whole squared, so diameter squared over 4. So we can replace this whole volume equation with pi times, instead of radius squared, d squared over 4, all multiplied by length. The uncertainty in the diameter is 2.37%. We found that. Because we're squaring the diameter, we're essentially doing diameter multiplied by diameter. And when you multiply, you actually add the percentage uncertainties. So adding these two together, we'll get 4.74%. So that's the percentage uncertainty in the diameter squared. I'm going to write that a little bigger. So that's the percentage uncertainty in diameter squared. We're then multiplying all of that. So pi is a constant. It doesn't have any uncertainty. Same with this 4. But then the length is giving you the absolute uncertainty. We take that absolute uncertainty, which is 2 millimeters, and we divide it by the actual value of 71, multiply that by 100, and that gives you the percentage uncertainty of the length. So 200 over 71 gives 2.82%. And as our final step, we mentioned that when you multiply variables, you add the percentage uncertainties. So we're multiplying by length again here, so we add together these percentage uncertainties. 4.7 plus 2.82 is equal to 7.52. Again, we're still dealing with percentages, but now it wants the uncertainty in millimeters cubed. So now we find the actual volume by using pi multiplied by d squared over 4. So diameter, we found the mean value is 33.8. All squared divided by 4 multiplied by the actual length, 71. So this will give you the actual volume. I'll show you why that's useful. Pi times 33.8 squared over 4 times 71. That's 63706. So that's the actual recording of the volume. And then we found that the volume has this much percentage uncertainty. So we then find 7.52% of that volume, and that's the actual uncertainty of the whole experiment. So let's find 7.52% of 63706. And that's our final answer. You can just multiply 63706 by 0.0752, because that'll find 7.52%, and that gives you 4790, or 4791, sorry. And that's your final answer to this question. Please let me know if you have any questions in the comments. Otherwise, thanks for watching. Please like and subscribe, and I'll post a new video tomorrow. I look forward to that. Bye.